Hello everyone, and thank you for joining our webinar today, .NET Pipeline on Windows Kubernetes. Today we'll have Jessica Deen from Microsoft Azure and Dan Garfield from Codefresh presenting. Remember that you can see all of our upcoming and past webinars on our website at codefresh.io/events, so make sure you check that out. All right, so today we have Jessica, who is a cloud developer advocate from Microsoft, focusing on Azure, Infrastructure Cloud, and OSS. She has spent over a decade as an IT consultant, system administrator for corporate enterprise environments, and she's a CrossFit and biking enthusiast. Dan is our Chief Evangelist at Codefresh. He's also a full-stack engineer, Kubernetes, all-around technology enthusiast, and builder of robotic chicken coops. So with that, I will go ahead and hand this off to Dan to begin our webinar.
Thank you very much, Taryn. So thanks everybody for joining us. This has been almost a year and a half in the making, actually. Jessica and I have talked about this a long time. We've had people asking us, how do you do Windows containers? How does it work? Can you do containers, Windows containers on Kubernetes? How does that work? Hopefully this is going to answer all the questions. And I'm looking in the poll results here, and it looks about half of you are getting ready to adopt Kubernetes but haven't started yet, with the other half being almost the whole other half either using it in test environments or using it in production. So we should have a good mix here. And to help me out, I brought in Jessica Deen, who's probably a bigger Linux nerd than I am, but knows Azure very well.
Yep, and it's kind of funny. We're both pretty much Linux nerds, but we can still get the Windows stuff working, which I think is kudos to the Windows team because it's easy enough for 2 Linux people to use.
Yeah.
All right, so agenda today. Before we dive into kind of how to play with Windows containers and party hard on Codefresh, we're going to first talk about containers and what are they. I know half of the people attending are considering pushing to Kubernetes, but we want to make sure we understand containers and Kubernetes orchestrators before we actually dive into it and show it. And then we're also going to talk a little bit about Codefresh and what it is and how it works, specifically how it works with Windows container deployments with Kubernetes. Dan's going to talk about that. And then we'll have some fun with how to set up Windows Kubernetes on Azure and then how to actually dive into the demo. So we're going to go ahead and quickly get started and dive right in. First off, let's talk about kind of what we hear from the people who are using technology, right? The people who are delivering software. So we're going to hear from developers and we're going to hear from IT. But for any of the people listening, tell me if this sounds familiar from a developer perspective. You need to create applications at a competitive rate without worrying about IT. You don't need IT to be the bottleneck, right? The applications that you test, that you hand off to IT, might run perfectly on your system, but the second they hit the IT server, things don't work. So then now again, there's still a bottleneck issue. So ultimately, as a developer, productivity and application innovation becomes suspended when you have to wait on IT. These are all problems that need to be addressed. This is a current state that's not in the container world. And from the IT perspective, don't worry, like Taryn said in the introduction, I came from a sysadmin background, so I have the IT background, I empathize as well. From the IT perspective, we need to manage our servers and maintain security compliance. I can't just let a developer party on my servers and install the application if I want to maintain my security compliance with my enterprise. On top of that, since I'm not natively a developer, I'm unsure of how to integrate this application I was handed from a developer into the infrastructure that exists. So I need to work with developers. We need to get rid of this wall, right? And then on top of that, we need to focus on both server protection and application compliance. So we kind of have this security that we have to deal with. So whether you're an IT pro or a developer, we both kind of have the same pain points. We don't need the developer being the bottleneck, and we don't need the IT pro being the bottleneck. So we need to find some sort of technology solution that can kind of bridge that gap. And that's where the IT stress points come in, right? No matter where we fall in the IT world, We all have to worry about security threats. We all have to worry about efficiency, and we all have to support innovation and growth that we see that's constantly changing in today's technology world. That's where cloud comes in. Okay, so the traditional model of technology was infrastructure that was dedicated for each project and for each application. The hardware we had was purpose-built. The infrastructure and operations teams were separate. That's why we had bottlenecks. We weren't working together. I often use an analogy where it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room, and no one's coming together and working together and having a good time. The processes and configurations we had were also customized for each application and for each project. A model like that isn't scalable. So that's where the cloud comes in. That's where containers comes in. That's where this new world really starts. The cloud model is based on loosely coupled apps and microservices, as opposed to giant monolithic services that take months to update. The hardware we have is now industry standard. Our service teams are service-focused DevOps teams, where we don't have any more of these silos. We're working on services that we're delivering for our company. And the process of configurations are standardized DevOps practices that really tie right into the cloud model and containers.
And I believe there's a law that your technology stack will always reflect your people stack, that the way that you work as teams will be reflected in the technology you choose. And so you kind of have to adopt both at the same time, right? I mean, you can throw containers into a traditional organization, but their sort of human networks should change to reflect this, which is the whole reason this DevOps thing exists.
Absolutely. And that's how containers really kind of plays into it. So we talked about developer pain points and operations pain points and this separation in this wall that used to exist. And as Dan said, when it really kind of does have to be a technology change and a people change, that's where containers comes in. For the developer, it really kind of enables this write once, run anywhere ability. And for the operations team, it addresses the portability. So when we talked about how the application might run on the developer's computer, but it doesn't work properly on the server, we can't guarantee that the server has stayed consistent throughout QA, staging, and prod. The ideal scenario is that it has, but in the container, you essentially have your runtime environment encapsulated. And we'll take a look at a graph on how that works. You're enabling microservice architecture with containers. You have standardized development, QA, and prod environments. Containers really kind of addresses that infrastructure change that's needed and addresses those pain points that both parties face. Now, what is a container? And this is the same thing whether it's a Linux container or a Windows container. So if you've seen some of Dan's and my other presentations, you might have already seen some of these slides before, but they're still relevant, and I want to make sure that we go over that. So a container, first off, is not a real thing. It is an application delivery mechanism with process isolation. And again, regardless of if it's a Windows container, it's actually based on what was traditionally several Linux kernel features. So you'll hear things like namespaces, which is what a process can see. That's things like your mounts, your networks, your users, your C groups. And your C groups is actually what a process can use. So that's hardware things like your memory, your CPU, your devices. And you'll kind of see as you start getting deeper into the Kubernetes world, how when you set out your declarative statements and you set out your deployments and your services, you can actually specify, and not actually as a can, it's what you should do, it's a best practice, where you can specify out your CPU resource usage, your limits and your minimum requirements. Same thing for your memory. So you define what is needed for your particular deployment. So your deployment doesn't exceed that and is guaranteed to be given at least that amount of memory and that amount of CPU usage. And another question that I always get asked is, we talk so much about Kubernetes, but what is Docker? How does Docker play into it? I thought Docker was a separate company. Well, yes and no. Docker, at the core base of it, is an open source container runtime. It has Mac, Linux, and Windows support, and primarily it's a command line tool. The standard file that we use to declare and build images is a Docker file, though Kubernetes does support other file formats as well. Typically, we use Docker though. And the Docker image format uses a layered file system. And again, this is the same whether it's Linux or Windows. So this is a screenshot where you'll see a Linux base, but we'll show a screenshot of what a Windows layer looks like on the next slide. The important part of this is you can see on how you're going to have a base image at the bottom, and then you have read-only layers that essentially are cached as part of your image. And all your read writes happen at the top of that image. That's where your application is actually running and doing any kind of information processing. So here's how it would look from a Windows image. And this is actually pulled from the Codefresh tool based on the image that we're going to build in today's demo. So you can see where I'm setting a label. You can see where I'm copying any kind of directory information, the working directory for the IIS website, the entry point. All of this is even where it's bullet running PowerShell commands. All of these are individual layers. So when I update one layer, it will only change that particular one that's been updated, and it leaves the other ones cached. Unless, of course, I disable caching. Now, how does containerization differ from virtualization? Of course, for virtualization, there's two different types of standard virtualizing infrastructure. Your first type is where you just have your hardware and your hypervisor sits directly on top of that. That might be like VMware or ESX, ESXi. And then, of course, you have your virtual machine that sits on top of your hypervisor. And within the VM, you're going to have a guest operating system, your dependencies, and your application. And it's up to you to make sure that the dependencies and the application are up to date and any dependencies are the correct version that's needed for that application. Similar to the second type of virtualizing, you'll have your hardware, but this time you have a host operating system. That might be like Windows Server, and then on top of that, you have your hypervisor, which might be like Hyper-V. And then again, still, it's going to be a virtual machine with a guest operating system, dependencies, and an application. But in the containerization world, you have your hardware, you have a host operating system, and then you kind of have a Docker engine that sits on top of that, which actually enables your container runtime ability. So any dependencies sit on top of the Docker engine layer, and then your containers have your application dependency and your application all built within that container itself as defined by your Docker image. So it really kind of makes that now portable and immutable.
Yeah, and to add on to this, the VM is going to be much heavier, right? Because it has to contain its own copy of the operating system. So it's going to have its own kernel. So in those diagrams, we have like 4 different kernels going on there. Whereas for the VMs, and they're going to be much heavier, they're going to be much larger. And they basically, you know, it's like somebody sat down and looked at it and they said, why do I have the same component existing in all of these places? That seems inefficient. What if I could use one kernel and then just kind of extend onto it for the only pieces I needed? And they did, and they made it, that's containers, right?
Yeah. It's really powerful because then that way you're able to keep your images as small as possible, which is also another best practice. So you'll also probably hear in, as you dive deeper into Kubernetes, is how to do multi-stage Docker builds. So you'll use a build image at the top that might have anything that you need to copy and actually compile your application. And then you'll have a runtime image at the very end, which is just the very bare minimum that's needed to actually run your application or your DLL. And that allows you to keep your image as small as possible and only use what's needed to run it. So you're able to have a faster image, a more portable image, a smaller image. It adds additional security benefits. All of that is possible by having your environment include process isolation and runtime encapsulation. So advantages of using containers. Remember, we identified problems in the beginning for both developers and IT. Again, using containers really addresses both of those problems. For developers, you're now able to iterate faster. You now have agile delivery. And again, everything is now immutable. And then for IT, there's additional cost savings. I'm not having to stand up and run multiple virtual machines for individual projects. I can run multiple containers and pods on one cluster. I can scale out my cluster with multiple nodes. I'm now able to have more efficient deployment. In Kubernetes, you use what's called a declarative language. So you're using YAML to essentially write the state of the world as you want it to be. And you can guarantee that that deployment is going to reoccur every time. You have schedulers where if a pod fails, the scheduler is going to automatically redeploy it as per that declarative statement you defined. So your deployment becomes more efficient. And then you even have elastic bursting, where based on certain hardware demands, you can go from the public cloud into the private cloud, or private cloud into the public cloud. Now we're going to talk about, again, how kind of you can use Windows containers with Kubernetes on Azure. Right now, AKS, or our managed version of Kubernetes, does not support Windows containers, but you can deploy it through ACS Engine. ACS Engine is our open source, available on GitHub. It's our open source engine that essentially our AKS system is kind of based on. Using ACS Engine, you can generate an ARM template or an Azure Resource Manager template that's going to set up your Docker-enabled clusters for Microsoft Azure. This actually supports not only Kubernetes, but DCOS and Docker Swarm as well. It's the input tool to essentially specify a cluster definition. And the cluster definition is very similar to the ARM template syntax that's used to deploy Microsoft Azure Container Service, or ACS. The cluster file definition will enable you to actually completely customize your Docker environment, where aside from choosing your choice of orchestrators, you can define your agent pool to be Linux or Windows. You can specify your VM sizes. This is where you can also enable GPU optimized environments. You can also set up virtual machine scale sets, availability sets, custom VNets, and extensions. It's really, really powerful, where you can start playing with it now. Is this something I would recommend 100% for a production environment? Honestly, no. But the purpose of today's webinar is to show that Windows Kubernetes deployments can be supported on Azure and from Codefresh, and to show you that the teams are actively working on this development. So don't wait for it to get into production before you become comfortable with understanding how these pipelines work for Windows deployments. Start playing with it now. Start getting comfortable with this abstraction today. And here's how that Windows on Kubernetes Azure deployment kind of looks. So on the left-hand side here, you'll actually see the master 0. The master 0 with the host address and the pods, this is actually a Linux master. Your nodes, or your agent pool, is actually Windows nodes. And so those Windows nodes are going to have a kubelet processing running on it. Kubelet processing running on it, and then the Docker engine running on it on both Windows nodes. And then same thing with your Linux master. You'll have your Azure load balancers, you have your availability set, and so on and so forth. So when you first do your deployment, and I'll show you what your template looks like with ACS Engine, you are going to be deploying a Linux node, but then you also are defining a Windows image for your agent pool, because those are your Windows workers that's going to actually handle your Windows deployments.
Now, interestingly, you can actually run Windows and Linux hybrid Kubernetes clusters where you can basically have node pools that are Linux, node pools that are Windows, and you kind of mix them. And to kind of come back to explain, why we're doing this. If you look back at that model when we were talking about how you're sharing kernel resources between containers, this makes it really clear why there's a difference between Windows containers and Linux containers, right? Linux containers are extensions onto a Linux kernel. Windows containers are an extension onto the host Windows kernel. And so that's why they're not quite mix and match like containers tend to be. Windows has two different modes for supporting containers. If you're using like Windows 10 or whatever modern Windows is, it actually has an embedded Linux kernel for running Linux containers. And then if you're running a Windows container, it will run off of the Windows kernel. So the challenge when you're doing this is twofold. One, having a host system that's running Windows, which in this case, Azure is going to handle for us swimmingly because you have this, that template that Jessica's talking about, and then there's a link to it later. And second is having a build system that can build these Windows containers. And this is where Codefresh is going to come in. So if you go to the next slide, we actually have two different models for how we do this at Codefresh. For those that aren't familiar with Codefresh, we're a CI/CD platform designed for Kubernetes. So we build, test, and deploy containers. We manage that life cycle for you. We connect from your commit all the way to the deployment. Jessica, will you go to the next slide?
Yes.
So the two different ways that we support building Windows containers, one is on the left here, a Windows node. This is basically a Windows VM that we connect to Codefresh, and it basically acts like a normal sort of build node that we have on Codefresh. It will build and run the pipeline on top of that node, and it has, you know, really great caching support, so builds happen very, very quickly, and a lot of sort of native support that's very, very good there. And this is what we're going to demo today. Is we've created a node on Azure that's Windows, and this is where we're gonna use it as our host environment to build our containers. The other model that we support is with an agent and a Windows-based Kubernetes cluster. Now this is a bit newer, as Jessica mentioned. Windows clusters are, let's say, uncommon in production at this point because it is still relatively new. But basically what it will do is it'll install an agent on your Kubernetes cluster, and it will have sort of behind the firewall access, and if you want to, all your code sort of stays on your Kubernetes cluster, but it's missing some of the kind of refinement of the Windows node, where maybe caching isn't as good and some of those other kinds of things. So the model we're using is the Windows node model, and hopefully that's all clear. And again, you know, feel free to make to make comments as you go along, and some of them will answer as we go along, and some will answer at the end.
Thanks, Dan. That was that's super helpful, and that's going to take us into our demo. So now that Dan kind of explained how the infrastructure and Codefresh is actually processing this, I'm going to go over to my Codefresh dashboard. And so there's a few different ways that you can deploy to a Windows cluster on Azure right from Codefresh. First off, if you don't go through a pipeline, which is not a best practice, but we want to show you the simplest way to get started, you'll see on the left-hand side here, and I don't know if Zoom supports me zooming in, but I'm going to try. Under build and test, you have repositories, you have pipelines, you have builds. And then under deploy, we have Kubernetes and Helm releases. One of the reasons why I love Codefresh for demos is that they give you really rich visibility and insight into your Kubernetes clusters, your Helm deployments, everything that you have running without having to connect to your Kubernetes dashboard API. So I can see everything that's currently in my Windows Kubernetes cluster. I also have a Linux Kubernetes cluster. I can see all my namespaces and all my deployments right from the dashboard under deploy. So right now in the default namespace, I have a few different services that are running, and we're going to go into how to deploy that. But let's say I wanted to add a new service without a pipeline. I could simply click this right from the dashboard and go in and add a new service manually. To do that, I would select the cluster, which I'm going to select my Windows K8s. I'm going to choose a namespace. I'll choose test. If I wanted to add a new namespace, which for any Windows users that's new, again, remember namespaces is kind of what a process can see. So it's a way to isolate your deployments. This way, if something, and it's a best practice. So if you deploy out to a namespace, which you should, and something goes wrong in that namespace, you only have to worry about that namespace kind of being blown up. You don't have to worry about it affecting anything else that's running in other namespaces. As you dive deeper into it and you start playing with things like role-based access control, you should all make sure that you lock down your RBAC to particular namespaces for deployments so that you don't just give every deployment essentially God mode access. But that's a deep dive for another talk. Just wanted to make sure we're explaining why I'm choosing to kind of isolate this test deployment for this demo. So I'm going to deploy it out into the test namespace. We'll go ahead and name this IIS webinar. I'm going to go ahead and expose the port. This is going to make sure that I'm going to not only do a deployment, but I'm going to also attach a service to that deployment. In Kubernetes, by default, if you just do a deployment, it's not going to be publicly exposed. You would need to attach a service to that deployment to make sure it would be publicly available. And there's 3 different types of services that you can enable. There would be cluster IP, there would be node port, and there would be load balancer. By checking this box, I'm essentially telling the Kubernetes deployment to create a load balancer and give me an IP address where I can view this application. From there, I'm going to specify an image. So I'll go ahead and call it the image that I need, not that I'm calling it. The image is a hosted image that's available on Docker Hub. It's a Microsoft-owned image, and it's an IIS Windows Server Core 1803 image. I don't need any server pull secrets or anything. It's a public image, and the internal port is just going to serve on port 80. So I'm exposing port 80, and the internal port from my container is port 80. That's it. So I specify the namespace, the service, and the image. I scroll a little bit down, and I hit deploy. So right from the Kubernetes service dashboard into my test namespace, you can see I have one service that's currently and actively deploying. It's right now deploying out. I can see the status, and I can see that it's pending pulling an IP address. Depending on how long this takes, Windows images are a little bit bigger than Linux images, though this is cached. So I can actually see that I've already pulled it on my node before. So the service and the deployment is already up and running, but I'm still waiting for it to grab an IP address from my Azure deployment. So we'll refresh this a few times. As soon as this gives me an IP address, we can actually see the image that I just deployed live right now. And once we view that, we'll go into how to do this kind of more from a DevOps pipeline approach, which is from a repository and a pipeline. So let's go ahead.
And in case it's not clear, what's happened here is the YAMLs, the service and deployment YAMLs have been automatically created based on the variables that Jessica put in here.
And you can see that YAML right here that's been automatically created. Codefresh has done that for me. So this was the quick that I was on, where I filled in all the information. And under YAML is where it's actually generated the YAML for me. So if I'm also, remember I mentioned that there's a different type of service that you can choose. This is the cluster IP, and then the type is a load balancer. I could change that type, and it would change the service. But if you're still new to learning Kubernetes and declarative deployments, this is a really great way to kind of see how that service is being created, how the YAML is being written. Under deployment, it says the same thing. Here's the metadata and the spec and the selectors and the templates and the image that's being used.
And you could take this YAML, save it to a file, throw it in your repo, and now you've got your Kubernetes YAML files, you know, on version control, and you can use them from there as well.
Yes, and so let's go back to the Kubernetes. No, I don't want to save the changes. We'll go back because it did pull an IP address. So we can actually go view that application live right now that was just deployed in a matter of seconds. The first time you do the deployment, again, remember, we'll have to pull the image, and that image is a little large, so it can take a minute or two. Don't be alarmed. But this is a live IIS Windows image that was just run and deployed from Codefresh. But let's switch back over to pipelines. So this is actually where we're reviewing the YAML, but I'll show you how I got there. If I go to repositories, this is a public repository. It's available. There'll be a link at the end of the slide. It's available on GitHub today. And I think Dan, I hear typing, so he might be throwing that in the chat window. But if we click into the GitHub repo, I have 2 different pipelines. We're going to go into our build and deploy pipeline right now. And you'll actually see that I have a trigger enabled, where it's enabled for my Git repo to listen to that repo anytime I make a change, which will make a live change. And then I have a YAML where I'm defining my build and release definition. So the first part is where I'm going to build a Docker image of a simple ASP, full-blown ASP MVC application. I'm going to tag it with the branch and the git SHA, and then I have a Docker file that's included and how it's going to build. And then it's going to deploy to Kubernetes using the image that we built in the previous step. And that image is actually hosted in Codefresh. So Codefresh will support, they actually give you, not support, but they give you private Docker image repositories for free, as well as Helm repositories, by the way. So let's go ahead and make a change. First, let's switch over to VS Code. And the first thing you can see, let me close this. The first thing you can see is my Codefresh YAML, which again is included in the GitHub repository. One thing I do want to highlight is this is the deployment file. All the how-tos, how to do all this. This is the deployment file to build your Windows Kubernetes cluster that I was mentioning. So this is where I'm defining the agent pool, where I'm specifying that I want to do a Windows agent. And then this is where I'm also specifying that this is going to be my Linux master node. And there's a detailed walkthrough that the Windows team wrote for you, and there's a link to that in the GitHub repo. But you would use this with ACS Engine to build your Kubernetes cluster. So now let's switch over to our full ASP.NET application. I have a application live right now that you could see. I'll refresh it. This is a live application that's set up as part of our pipeline. It's just a simple ASP.NET application. There's nothing fancy about what's written in this part of the window. So I'm going to go ahead and add a section right here where I'm going to say, hello, Codefresh webinar viewers. We'll save that. I'm going to go over to Git. I'm going to check that in, and we'll say live demo change. We'll commit it, and I'll go ahead and push it. Once I push it, since I have a trigger listening on that Codefresh pipeline in that repository, it's going to automatically kick off a build, and we can watch as it kicks off. Now, this will take about 3 minutes or so because I don't have any caching enabled. I want you to see how it's building every single layer, and this is a live Windows build. It's kicking off from the build and deploy pipeline I showed you, from the master branch, from the most recent Git push. If I go over to the Git repository and I hit refresh, you'll see that that latest commit matches. It fetches the latest commit. 40 seconds ago, B88C0BB, live demo change. Switch back over here, B88C0BB. So we'll click into it, and you can actually watch as it is building the Docker image. And this is the same Docker image that we're going to use for the deployment. And after it pushes out a rolling deployment to our cluster, we'll go back over to the MVC app, refresh, and we'll see our change live. So this is no smoke and mirrors. This is a live change. Codefresh is doing a Windows deployment, and this is a Windows Kubernetes cluster running on Azure deployed by ACS Engine.
Yeah, so the magic here is having the workflow engine run on a Windows node, and that's what allows us to build the Windows image. And one of the things that makes this unique, one of the things that makes Codefresh unique is that each of these steps that you see here, we're on our third step, it actually runs inside of its own container. And so this gives you a lot of control and power over how your pipeline functions, how caching functions, and it means that you are liberated from things like code conflicts. If you're using different versions of different libraries for different steps, it means that you're not worried about having collisions from having a plugin that's installed that is this version of Terraform, and I update it and it breaks everybody else's pipelines. You don't have any of those kinds of problems because each step only comes with the tool set that you specified, right? And so that's kind of how it functions.
Yep. And it's cool because you can see as it's pushing each individual layer, it's pushing it to the RCFCRIO. That's my repository, and we'll go take a look at that under images after this gets done. And the cool thing is, by the way, as I pointed out earlier under Kubernetes, you can see your services. So we'll go take a look at that in just a second as well. You can watch as it's deploying to the cluster right now. I have one replica. It can see that it's meeting the conditions. It has all the available resources that's needed. So it's going to pull my image, and it's going to go ahead and update the deployment that exists. This does take about 3 minutes total when it's the first run. If you have caching enabled, it's obviously going to be a little bit faster, but it is waiting for the rollout to finish. So one old replica is going to terminate, and it's firing up a new container. So there's virtually no downtime is the point of that. So if we go over to under Kubernetes, under services, you can see the old image that was pulled, viewed at this endpoint for this service. But if I update this, we should see that new image pulled, the 880BB. It's currently red. So the deployment has minimum availability. Let's update now. Might still be doing a rolling update, which it looks like it was. Now it's green. This is why I said I love that Codefresh gives you this rich visibility dashboard. I don't have to have multiple screens up. I don't have to have different terminal command lines, watch commands. It makes it really clean. So that's the same endpoint, which I'm already viewed here, 40.76.53.7. We'll just simply refresh. It's not a different IP address or anything. And we should see our change live now, as soon as this reloads and re-clears. It's still loading. There we go. Hello, Codefresh webinar viewers. So it's a live rolling update that we could be able to see. And I told you that we'd see where the images are. The images are in artifacts. So if I go to artifacts, I can actually see my image repository, which was for the ASP.NET MVC app live demo change. I can even see that tag. I can click into that image. I can see a summary of all the information. If I wanted to push annotations, I could do that as part of my pipeline. There's a demo of how to do annotations for that on my Croc Hunter repo. You can see the Docker file that was used, any additional layer that was pulled, and you can actually see the layers that were built. This is the screenshot that I showed you earlier in the slide deck. So let's go back over to the slide.
One other thing, actually, Jessica.
Yep.
While you're there, if you go to that Kubernetes space where we were looking,
okay.
I find that a common problem is just to understand what's running and where did it come from. And so this is the app we're working on. Click on the image from here because we can see what's running. We can see it's up and running. And this will take you to that same screen. And then if we wanted to understand, what change was made that created this image, what even got us here. So if you're trying to track down a problem, you're trying to figure out what changes went into it, who worked on it. If you click on that commit SHA, which is on the left-hand side.
Sorry, it's taking a second to load.
Coming up here.
There we go.
Yeah, if you click on that commit SHA, this will actually show the diff in our Git provider of the code that was changed between the last version and this version. And now, if we're trying to track down issues or figure out who worked on something, we have basically a line all the way from the deployment back to the commit, and we can see what's running in production, who worked on it, where did it come from, who pushed it.
Yeah, this is really powerful. Like I said, really rich visibility and granularity into your deployments, whether they're Linux or Windows. It works the same way. So we'll go back over. We're now at the questions part of our presentation. There's no more slides really. We wanted to leave plenty of talking time because I know that this is still a new topic. This is an active development. At some point when we start supporting better scenarios and have more stability with SQL Server and Open Azure Service Broker and the Windows team, we'll definitely have an updated webinar. But we wanted to kind of get everyone's feet wet and comfortable with Windows containers, setting up a Windows Kubernetes cluster, setting up a Codefresh Kubernetes pipeline for Windows. And then if there's any questions, Dan and I are more than happy to answer them now.
Yeah, and we've got a couple of questions. Feel free to add them into the QA. There were a few questions about running hybrid clusters, and truthfully, it was kind of a throwaway line in this. We didn't have a big focus on hybrid clusters. I put a link to a blog post in the Q&A. So if you click on that, you can see a blog post on how to do hybrid clusters. I don't necessarily recommend hybrid clusters. I think it's more like oh, cool, you can do that. I would prefer to keep them separate just because I don't want to ever have crossover between. I don't want to cross the streams. You don't want to cross the streams. Bad things could happen. You start trying to deploy containers into the wrong nodes, and it will be sad. But another question, this one's for you, Jessica. Does the Kubernetes for Windows work on Windows 2008?
So for Raphael, can you clarify that? Are you talking about Windows Server 2008? Because if so, Windows Server 2008 and 2008 R2, as far as I know, is end of support, end of life, and the hypervisor is completely different than Windows Server 2016, which was kind of designed for their orchestration. So
I don't know. I would think that he means, can you build a container that relies on Windows 2008 and run that? Well, yeah, Windows Server. He says yes, Windows Server 2008.
Okay, so then my question is, what would be the use case for that? Why do you need a container with Windows Server 2008 when it's end of support, end of life? Legacy infrastructure. That's the part of lift and shift, and it's time to migrate. You want to migrate into something that's not dependent on legacy infrastructure. Be able to migrate to Windows Server 2016. You don't necessarily need the Windows Server underlining. You need to I mean, when you're deploying out a Windows Server cluster, you need IIS, you might need SQL, but as far as legacy infrastructure, when it's end of support, end of life, it's going to be really hard to backdate orchestration when orchestration wasn't popularly even used in 2008, if that makes sense.
Yeah, 2008 doesn't seem like very long ago, but if I do look at the date, it is like 10 years ago, so it is a bit rough. And I don't know how difficult the transition from Windows 2008 to 2016 is. I haven't done that before, but
well, I mean, so when you're setting up your cluster, let me go back over to Visual Studio Code, and I guess I'll minimize my QA questions, or try to. There we go. We'll go back over to the Windows Kubernetes deployment. So where I'm actually deploying Windows, you can specify the operating system image that you want to use for your agent pool, but in no way, shape, or form would I recommend using a Windows 2008 R2 image. It's too outdated and it's too legacy.
so there is one available.
Well, I mean, there's an image that I don't even know if there's an image in Azure. We can go check.
Okay.
I know there's a command you can use to actually get it from the command line, but let's go. I know that for a lot of Windows users, command line is still quite scary. So we can actually go to the portal and see different images that exist. I don't know, I've never tested a Windows 2008 in a Kubernetes image, but as far as I know, let's also double check. Windows 2008 R2. I believe it's also end of support this year or next year. I mean, to me, that would be the equivalent of, can I run Windows XP in my cluster? Which, I mean, I guess legacy support, but why? Yeah, on January, okay, so it's end of support in 2020. So it won't even be receiving security updates.
Thank you, Raphael, for that question, and hopefully that's helpful. So we had a question from Jasmine. How is Codefresh different from CodeShip or Jenkins X? That's a great question. So from the beginning here, Codefresh was designed specifically with the use case of I want to deliver containers into production, and CodeShip is a bit more older than that. They kind of have more of a focus of just using containers and using sort of a containerized infrastructure for its pipelines, but it doesn't necessarily have using every step as a container and seeing what's running in Kubernetes, having that dashboard. We didn't really get into Helm. The Helm support in Codefresh is way beyond what's in CodeShip. Jenkins X is an interesting project. Nobody's really using Jenkins X for sort of production CI/CD pipelines yet. Or at least I haven't run into anybody that is. Jenkins X has a little bit more focus on the local developer experience, and to do that, they package together some open source tools. There's a tool called, I forgot what it's called, but basically what it does is every time you save a change, it will automatically build and push to like Minikube, which is good for local development, but not necessarily the right tool for delivering something to production. Jenkins X doesn't have a UI today, pure command line tool. I think they've done some interesting things from a local developer standpoint, but as far as running several people through it, having permissions and having a dashboard, seeing what's running, having the traceability, Codefresh is really meant to cover the whole range from CI to CD, so from commit to deploy. So hopefully that answers your question. Chris asks, how can we try this out? I'll share a link in the chat here to our POC form, which you can fill out, and we can get you set up with basically a test run of this stuff, and we'll walk you through creating a Windows node or using a Windows Kubernetes cluster as your trial. And then Jessica, with Azure, there's like $300 of credits or something when you first sign up. You get some free
$200 worth of credits. So that's on this slide. Let me again minimize this window for my questions. Click over to the next slide. Whoops. There we go. So this is where all the demo stuff that I showed you today lives on GitHub. And then if you go to this link, you'll get 12 months of free services, and then a $200 credit on Azure if you're new. As far as creating a Windows Kubernetes cluster, when you go to the README of my demo, there's actually guidance on how to deploy it using ACS Engine. So we walk you through every step. Patrick Lang, actually, who's on the Windows Kubernetes team, who unfortunately couldn't actually make the webinar today, but he completely rewrote this entire walkthrough, which will walk you through from beginning to end, even down to setting up your environment, creating a resource group, getting comfortable with ARM templates. And this will help you deploy out a Kubernetes cluster working on Windows, just like what I have today. Let me see, there were a few other questions I did want to answer. So one person said, did I understand you correctly that the Kubernetes for Windows master nodes runs on a Linux kernel? So there's a master that's, yes, Linux based, but where your agents are actually like deploying and running your containers are Windows nodes. So the pod itself is running on Windows workers. There's 2 nodes by default. You can see that in the deployment. I'm standing up where I'm telling it to deploy. On the agent pool profile, I'm telling it to set up a Windows pool with 2 VMs that are Windows. But the master is a standard image that's using Linux. And so on the master is things like the scheduler and etcd and the API server. And it's essentially taking that deployment I want to deploy and it's handing it off to the agent pool for Windows. So it's not a Windows container running on a Linux kernel. The only thing that's using the Linux kernel is the master. That's essentially the scheduler and the API server that's telling the Windows nodes what to do and to deploy it.
Yeah, and so there's no conflict there in having a Linux master running your Kubernetes cluster, because none of the stuff you deploy is going to be on a master node
No,
like that.
it's in your agent pool. And that's also one of the benefits when you get down into like managed Kubernetes, which is AKS, which again currently only supports Linux at this time. You don't even end up seeing the master or the control plane. All you have to worry about is the agent pool. So it makes it very easy to scale your cluster up. If you want to go from 3 nodes to 10 to 50, you can easily upgrade the version of Kubernetes. It's a lot easier to manage. Now the next question, sorry, go ahead.
Oh yeah, I was going to read it for you. It's because it's for you. I'm
Yep.
very interested in running Windows SQL Server and ASP.NET deployments in Kubernetes. How is Microsoft Windows team progressing on smaller Docker images for SQL Server on Windows? Right now, they're quite large.
Yes, so the Windows team is in active development on all things for containers. Right now, there's a lot of momentum in the container space, so the team is working as fast as they can to really kind of improve. I know that one of the things they're working on is actually even using Azure Open Service Broker for SQL deployments as well, which doesn't work at this time, but is on a to-do list, where my understanding is that would make the images smaller. Part of the issue is Windows images as a whole have always been significantly larger than Linux. So there's a bunch of kind of refactoring that needs to happen in order to make sure that those images are quite small. I think even the IIS image right now is like over a gig, which is insane when you consider Alpine Linux is like 15 megabytes. Like I can have an Alpine Linux runtime container that's 6 megabytes. I mean, it's just ridiculous. So I know the team is working on it, but all I can say is that it's in active development.
So I'm going to answer one more question, and while we do, I'm just going to send out a poll just asking for feedback on how this webinar was as we finish up. There was a question of, does Codefresh have a CLI? The answer is yes. I put a link in the chat. You can download and run that from your local machine, and you can fire off pipelines, see what's going on. For those that have feedback on if you feel like you didn't get what you wanted, if you feel like there was more that you wanted to understand, please put it in the chat, help us understand what you're looking for, and maybe we'll put together a webinar on that next time. I would also say, if you want to try this stuff out, create a free Codefresh account and you can start playing around with it. To use the Windows nodes, you do need to open a POC. So I put a link to that in the chat. And then Azure does have the $200 credits, which you can use with Codefresh's 120 free builds a month. So you can actually start playing with this stuff and see how it works. Jessica, anything else that you want to add?
Yes, I do want to show something that's new to Codefresh, where actually if you have an Azure account, you can sign up for Codefresh using your Azure account. And I'm going to show you how to do that real quick, and then that's going to be the end of whatever I have. So if you want to create an account, going to Codefresh, you just hit create account, and then one of the options, as soon as this gets done loading, is going to say Azure right here. So you can actually sign up with your Azure account that you create with the $200 credit. And this is very new. I think we just launched that a few weeks ago, right, Dan?
Yeah, it just launched 2 weeks ago. So
yeah,
new stuff. That's the new hotness. Well, with that, thank you very much, everyone. We really appreciate you coming out. As you see, go to codefresh.io/events to see all of the other webinars we have coming up. We have lots coming up all the time. Jessica Deen has a packed schedule. You can follow her at JL Deen on Twitter. I'm at Today Was Awesome. And that's it for us. Thank you very much for coming.
Thank you, everyone.